modify or change these components without affecting the other components, and even modify the underlying operating systems as required. And that search landed me on Docker. With Docker, I was able to run each component in a separate container with its own dependencies and its own libraries, all on the same VM and the OS, but within separate environments or containers. We just had to build the Docker configuration once, and all our developers could now get started with a simple Docker run command. Irrespective of what the underlying operating system they're on, all they needed to do was to make sure they had Docker installed on their systems. So what are containers? Containers are completely isolated environments, as in they can have their own processes or services, their own network interfaces, their own mounts, just like virtual machines, except they all share the same OS kernel. We will look at what that means in a bit, but it's also important to note that containers are not new with Docker. Containers have existed for about 10 years now, and some of the different types of containers are LXC, LXD, LXCFS, etc. Docker utilizes LXC containers. Setting up these container environments is hard as they are very low level, and that is where Docker offers a high-level tool with several powerful functionalities, making it really easy for end users like us. To understand how Docker works, let us revisit some basic concepts of operating systems first. If you look at operating systems like Ubuntu, Fedora, SUSE, or CentOS, they all consist of two things: an OS kernel and a set of software. The OS kernel is responsible for interacting with the underlying hardware, while the OS kernel remains the same, which is Linux in this case. It's the software above it that makes these operating systems different. This software may consist of a different user interface, drivers, compilers, file managers, developer tools, etc. So you have a common Linux kernel shared across all OSs, and some custom software that differentiate operating systems from each other. We said earlier that Docker containers share the underlying kernel. So what does that actually mean, sharing the kernel? Let's say we have a system with an Ubuntu OS with Docker installed on it. Docker can run any flavor of OS on top of it as long as they are all based on the same kernel, in this case, Linux. If the underlying OS is Ubuntu, Docker can run a container based on another distribution like Debian, Fedora, SUSE, or CentOS. Each Docker container only has the additional software that we just talked about in the previous slide that makes these operating systems different, and Docker utilizes the underlying kernel of the Docker host, which works with all OSs above. So what is an OS that do not share the same kernel as this? Windows. And so you won't be able to run a Windows-based container on a Docker host with Linux on it. For that, you will require Docker on a Windows server. Now, it is when I say this that most of my students go, hey, hold on there, that's not true. And they install Docker on Windows, run a container based on Linux, and go, see, it's possible. Well, when you install Docker on Windows and run a Linux container on Windows, you're not really running a Linux container on Windows. Windows runs a Linux container on a Linux virtual machine under the hoods. So it's really Linux container on Linux virtual machine on Windows. We discuss more about this on the Docker on Windows or Mac later during this course. Now you might ask, isn't that a disadvantage then, not being able to run another kernel on the OS? The answer is no, because unlike hypervisors, Docker is not meant to virtualize and run different operating systems and kernels on the same hardware. The main purpose of Docker is to package and containerize applications and to ship them and to run them anywhere, anytime, as many times as you want. So that brings us to the differences between virtual machines and containers, something that we tend to do, especially those from a virtualization background. As you can see on the right, in case of Docker, we have the underlying hardware, infrastructure, and then the OS, and then Docker installed on the OS. Docker then manages the containers that run with libraries and dependencies alone. In case of virtual machines, we have the hypervisor like ESX on the hardware, and then the virtual machines on them. As you can see, each virtual machine has its own OS inside it, and then the dependencies, and then the application. The overhead causes higher utilization of underlying resources, as there are multiple virtual operating systems and kernels running. The virtual machines also consume higher disk space, as each VM is heavy and is usually in gigabytes in size, whereas Docker containers are lightweight and are usually in megabytes in size. This allows Docker containers to boot up faster, usually in a matter of seconds, whereas VMs, as we know, takes minutes to boot up as it needs to boot up the entire operating system. It is also important to note that Docker